Okay, so I will start my today with another coding practice. So in this video, I will solve a question, LRU Cache. So this is one of the most famous questions in LeetCode and probably one of the most frequently asked questions in the coding interviews. So actually, I solved this question so many times in my life, but I decided to solve this question again and also shoot a video, again. So in this question, I will design a data structure that follows the constraint of least recently used cache. So basically, what I will build is the key value data store. However, if it sustains all the key value pairs forever, the size of the data store becomes bigger and bigger. So to avoid that issue, this cache will delete the key value pair which has not recently used if the size goes up some threshold. Yeah. So in my implementation, I initiate the LRU cache with the capacity, which is a positive size. And also get method returns the value of key if the key exists, otherwise it returns -1. And put method updates the value of key if the key exists, otherwise add the key value pair to the cache. I create a new key value pair. And if the number of keys exceeds the capacity from this operation, it picks the least recently used key. I see. Okay. The function get and put must run in over one average time component. I see. Okay. So let me think with an example. So if I use one, say I will initiate the LRU cache with size 2. Then, for example, I put the right 1, 2, or let me say 122. And now the cache becomes 1 to 22. Then if I try to get if I try to get 1, this will return 22. However, if I try to get 2, this will return -1 because the key value doesn't exist. And then if I say put 2 11 22, this returns nothing. And when I try to get 1 again, this returns 11. Then when I put 3 32 33, this does nothing. But after that, when I try to get 2, this returns -1. Because, okay, sorry, I didn't write the status of the data structure, LRU cache. So in line 7, it's okay. In line 8, I try to get key 2, but it doesn't exist. And in line 9, I put 222, like this. Then in line 10, I try to get 1, and this one is get. Then in line 11, I put 333. And after that, I will try to get 2, but this 222 is already evicted because it recently used key. So let me say 111 is added first and 222 is added second. But after that, 111 is accessed. So let me say if I sort this in this order, key value pairs, now when I put 222, it was the latest. Yeah, it was good. Oh, sorry. However, when I get 1, this 111 becomes the latest one. Yeah. Then when I get put 33, this becomes the latest one. Then I try to get 2. Oh, but when I put this 333, this 222 is evicted because the size is now more than capacity 2. And then in line 13, I return -1. Okay, so this is a basic example I can show. But just in case, let me reverse the order of this in my implementation. Because it's more, intuitive for me. Maybe this is just my preference, but yeah, I'd like to evict from the tail. Okay. So the brute force approach of this implementation of, LRU Cache is, sorry. I will put the key to the I will keep store of the hash map, which has whose value is value and also with timestamp. So in this way, or maybe I can say, yeah, right. So in this way, what happens is that after I pushing or getting the element timestamp with updated with the latest one versus the current timestamp, and then every time I try to put the new key value, every time I append the new key value, I will find the oldest timestamp, and I will evict that key if the size exceeds the capacity. So that's the basic approach. So in this way, the get time complexity is always constant because I just have to, look up from the hash map. However, for put operation, in the worst case, I always have to take care of look for the oldest timestamp and derate it. So it will take all of capacity. Yeah. But my task is to, get and put in constant time. So let me think the optimization. So the biggest problem of finding the brute force approach was that to find the timestamp which is the oldest, I had to reverse all the element in the key value pair. And to avoid that, I can use the double linked list as the helper data structure. So I will keep track of the key value pair. And also I will have the double linked list. So like if I get 1, 2, 3, and if I put 1 to 3 in this order, it should be something like this. And the key point here is that I will, for each node, this has a pointer to the original key value pair here. Okay. So in that way, say I have to append node 4, this will be something like this. Oh, sorry. I said latest one comes first. Yeah. So if I append 4, it becomes like this. And after that, I will evict this one. So probably I need the tail, sorry, pointer, so that I can find which, one is the oldest key-value pair. So when in this way, I can find the oldest key, and then this node has the pointer to the key-value pair, so it will be pointing to this one. 11 node, so I can get the value 11. The reason why I used not only doubly linked list but also the map is for the get method. If I'm asked get 2, and if I have only doubly linked list with key-value pair inside of each node, I have to find node 2, but it takes so much time. So instead of that, I will take care of node 2 in the hash map. Then I will get node 20. Oh, wait a minute. No, sorry. So it should be this map should point to key number to the value node. Yeah. So if I'm asked to get node 2, I have the pointer, I have the reference to node 22. So I can take a look at this node. Then I will return the node value 22. And when I do that, when I do the get method, I have to move this 22 to the top, head. Because, yeah, it's now, used the most recently. So let me quickly, review my design. So for the get method, I can return the value immediately by looking at the map, and then I get node, corresponding node. Then I will take a look at the node.value. And also, I have to do move the node to the head. Yeah. Because node to head. Because it's the recently used, the most recently used one. And for put, so there are two possibilities. If the key exists, and if key does not exist. So if key already exists, what I should do is update the node. So firstly, delete key in map and node from DDL, double linked list. Then add new key and then also I have to initiate the new node and put it into the hash map and also into double linked list. And if it does not exist, I just have to do this one same. And also in the end, I have to remove the tail node from DDL and set key from map. In this way, I have to make sure that the size of the cache store doesn't exceed. Okay, so let me. Oh, so in this way, all the operation should be the constant time. Okay, so let me get started. So I would say body pair map for also I will have the double ranked list. So let me check. So I will define the node class of the linked list. I need to store key and body because when I say in line 32, when I remove the tail from the node, I also have to remove it from the hash map. So for that, when I take a look at node, I also have to know which key it is. Okay, so this is a node class. So this is double ranked list, and I put the pseudo node in as the head and tail. So it should be like this. So this makes the implementation much easier because I don't have to take care of the two cases when node is known, when head is known or not. So I can generalize each of them with this to the head. So yeah, I appended it. Like this. So that being said, I currently have the list and yeah, double ranked list. Sorry, double ranked list and map. Okay, so the next thing I will do is implement get and put method. But let me just create another layer of operation in this class. So when I do a kind of like remove node from, so I will do some operations onto this double ranked list, like removing head, removing some node, inserting some node into the head, removing node from tail or something like that. So for those operations, I will create a sub method and abstract it. And I will use that, sub method in each of get and put. Yeah, so I will do it in that way. So let me implement get first. So for get, I will look at the key in the key to node hash map. Firstly, if the key doesn't exist, I will just return -1. And if there is, I will take a look at the node. Yes. Then what I should do next is, returned value should be node.var. It's okay. But also I have to do something. I have to move that node to the head of the double linked list. So let me say self.move to head node. I will implement this later, but in this way I can move the node to the head. Okay, then I will return node.var. Okay, good. There's no, the size limit exceeded doesn't exist in just getting the key repair. So it's okay. Okay, then the next thing I will do is put method. So firstly, for put, if the key exists, I will delete key in the map and node from DDL. So in the put method, I will firstly completely delete the key repair which exists already with the same key. So what I will do is self.key to node. This. And I will do it in just in case if there is. I will delete this node, so and also I will remove this node from the double ranked list. I would say remove node this. So now the existing key repair is completely deleted. So I will, insert the new node to the double linked list and register it to the hash map. So I will initiate this and also I will put this to the head. And also after that, if the size exceeds, I will remove the tail element. Yeah. Okay. Then, but also I have to delete this key value pair from key to node hash map. So from this remove tail method, I will return removed node. Then I will, unregister from the key value pair. No, key to node hash map. Yep, this is it. So the method I will implement are move to head method, inserting head method, and also remove tail method. Okay. Good. Wait a minute. Move to. So wait a minute. So first thing I just come up with is this move to head method is actually removing head, removing a node, specified node, and then inserting it into the head. So this move to head is equal to inserting head plus remove tail. So I don't define this function, but instead in line 59, I will do that. I will call these two methods. Move to head. Wait. Remove tail. Remove. Oh, sorry. I was mentioning remove node instead. And so let me oh sorry, remove node doesn't return remove node because it's already given. Yes, so instead of move to head, I used remove node and then inserting head. Okay. And also for remove tail method, I think I know why is a tail node, because it has the, tail of the double linked list. So instead of removing tail, I will just remove node. Then I will do the removed node. Good. So now I can forget remove tail. Oh, and I actually didn't have to return removed node even if I use the remove tail, because I can access it to the wrist tail from the getter put methods. Okay. Yeah, so now we're going to implement the sub methods inserting head and remove head. For inserting head, this is the current node, current head. Oh. And if I insert 22, I have to insert it here. This is current head. This is node. So I have to do self dot list head dot next is and also yep. Okay. In this way, I could insert node 22, I mean the given node, to the original double rate rest. Let me make this variable so it's more easy to understand. Okay. Good. So for remove node, so what I should do is assuming that this is the node I have here. So my task is remove this node. So prev should be node.prev and next should be node.next. So I will connect prev and next node. Prev.next is next node and next dot prev is prev node. Okay, good. So this is what I should do. Okay, let me quickly walk through the main method only. So assuming that it's too long to walk through, but yeah, instead of using the example, I just read the code. So for initialize method, I just store capacity as the instance variable. Then key to node should be the hash map key to the node instance. Then also I will have the list head, list tail, which pointing to the pseudo head and pseudo node at the current moment. And I will connect pseudo head and pseudo node. to the tail. Okay. Then for get method, if the key doesn't exist, I will return -1. And in line 57, if there's a node, I should remove that node from the double ranked list. And I will insert it into the head. So this line 59 and 60 is basically what it's doing is moving the current node to head. Okay. Then in line 63, with method, firstly I will check if the key already exists in this cache. If it exists, I will delete it. Okay. Then I will initiate a new node. Then I will register it into the map in line 70 and also insert it in the double ranked trace as the head because it's a radius. It has a radius access. Then if the limit exceeds, I need to delete it from the line from the hash map and also from the double ranked trace. Let me just rename it to evicted. Okay, good. Let me execute my code. Okay. Wrist head dot oh. Okay. I see. Pseudo head dot next is node prep should be. Good, it accepted. So I will submit my code and it becomes runtime error key error 0 in 7. Okay, here in line 75, somehow evicted node dot key should be deleted because node dot key is the key of the key value pairs, so it should be deleted from the hash map. So remove node, to deleted node. Good, now it's accepted. So I'm quite fortunate that my solution was accepted with the first try. Actually, not first try, but yeah, instead of the small trivial errors, it's the first try. Because if my logic is somewhere wrong, I have to debug it, and it totally is a hell for this question to debug. So I don't want to do it, but fortunately I couldn't do it. I didn't have to do it this time, so it was really good. Okay, so let me quickly wrap up. So in this question, I implemented the LRU cache. And LRU cache is a kind of key value data store, but only difference from the or ordinary hash map is if the size of the key-value pairs exceeds the given capacity, the least recently used key-value pair should be removed. And when I say least recently used key-value pair, it's the key-value pairs that it wasn't either got or put recently. Yeah. Or I should say added or updated, nor sorry, it hasn't been updated nor created nor used, accessed. So it's a recently used key. And that being said, in my LRU cache, I initiate the cache with double linked list and hash map. And hash map stores key to the node, and double linked list node should store key value pair as the attributes. And for the get method, yeah, I take a look at the key value pair. I take a look at the hash map, and then I can access the node. So I return the node.value, and also one thing I shouldn't forget is I have to remove the node to the head because it's now accessed. And for put method, so if firstly I cleared, removed the existing key value pair, which has the same key. Then from after that, in line 69, I initiated a new node. Then I registered it into the hash map and also put it as the head of the doubly linked list. And also after that, if the doubly linked list size exceeds the capacity, I evict the tail node. So that's the main approach. And also, the one technique I use is that I created the sub methods, and they're responsible for kind of row operation to the double linked list. In that way, my code is more readable. Okay, thank you so much. I finished my today's practice with this. Bye.